We discussed about the first application of the crossed fields, that is velocity selector, and the second application is cyclotron. Cyclotron is a machine to accelerate charged particles to high energies. That is, it accelerates charged particles. Accelerates means it changes the velocity. That is, it increases the speed. That is, speed is the magnitude of velocity, no? So, the cyclotron increases the speed of the charged particle. When speed is increased, kinetic energy also is increased because kinetic energy is half mv square. So, a cyclotron is a machine to accelerate charged particles to high energies. Crossed fields, that is perpendicular electric field and magnetic field, are used in cyclotron. Principle of cyclotron is that the frequency of revolution of charged particle in a magnetic field is independent of its energy. When we discussed about the motion of a charged particle in perpendicular magnetic field, we have got the expression for frequency of revolution. And it is said that the frequency of revolution of charged particle is independent of its energy. That principle is used here in the cyclotron. Next, let us see the working of cyclotron. It is the schematic diagram of a cyclotron. It consists of two D-shaped metallic containers. They are known as Ds. The two Ds are D1 and D2, and they are connected across an oscillator. Oscillator is a source of alternating voltage. Alternating voltage means the polarity of voltage will change alternatively from positive to negative, from negative to positive, like that. The oscillator creates a potential difference between the two Ds, and there will be an electric field in this gap between the two Ds. Electric field will be there only in this gap between two Ds. Perpendicular magnetic field is there and represented using these dots, blue color dots. That is, magnetic field is out of the plane. And here is an exit. After getting accelerated, the charged particle comes outside through this exit. All the arrangement is kept inside a chamber, evacuated chamber, to avoid any other collisions. Cyclotron contains two semicircular metallic containers known as Ds. Inside the Ds, there are no electric field, but perpendicular magnetic field is there, which makes the particles to go in a circular path inside a D. That is very important point. Then two Ds are connected with an oscillator, which creates a potential difference between two Ds. That is, electric field is there in the gap between two Ds. Every time the particle moves from one D to another, it is acted upon electric field, because electric field is only in that space between two Ds. Therefore, whenever the particle moves from one D to another D, it will be acted by electric field. In the electric field, the charged particle is accelerated. That is, expression is given as A is equal to E divided by tau, and hence its speed and energy are increased. For circular path, radius r is equal to mv divided by qb. We know accelerated means its acceleration is, its speed is increased. So when speed is increased, radius also increased. Each time when the charged particle moves from one D to another, it gets accelerated and hence its speed, energy, radius are increased. So the path of particle is spiral one. Let us see the working here in detail. It is the cyclotron setup. You can see two Ds here. That is semicircular metallic containers. The two Ds are connected with an oscillator. When the oscillator is switched on, one D will get positive polarity and the second D will get negative polarity. As a result, an electric field will be set up in this gap between two Ds. You know, the direction of electric field is from positive to negative. Two electromagnets are kept like this, one upside and one downside, to provide perpendicular magnetic field. These yellow colored lines are perpendicular magnetic field lines. These field lines are perpendicular to the Ds. So you can see here there is crossed electromagnetic field. All the setup is enclosed like this in a chamber. First, keep the charged particle like this in the gap between two Ds. When the oscillator is switched on, one D will get positive polarity, the second one will get negative polarity, and as a result an electric field is set up in this region between two Ds. Electric field will be only in this region. There will be no electric field inside the Ds. Now the charged particle is in this electric field. What will happen when a charged particle is kept in an electric field? Yes, it will experience an electric force is equal to Q into E. Also, it will experience an acceleration A is equal to QE divided by M. This equation you have studied in the first chapter. Now, the charged particle will get an acceleration. Moreover, suppose the charged particle is a positive charged particle, then it will get attracted towards the negative D. So it will move towards negative D, that is D1, with an acceleration, that is with an increase in speed. Then when the charged particle reaches this point, its velocity or its speed is increased to the value v. Now it enters the D1. But inside the D, there is no electric field. Electric field is only in this region. But inside the D, that is D1, there is magnetic field. So this charged particle is moving perpendicular to the magnetic field. Then in a perpendicular magnetic field, how a charged particle will move? In circular motion. Therefore, it will follow a circular path. Like this. It will follow a circular path. And when the charged particle completes a semicircle and reaches this point, the polarity of the first D1 is changed to positive and the polarity of D2 is changed to negative. The time period of the oscillator is adjusted in this way, that is, the time when the charged particle completes a semicircle, the polarity of the D's changes. Now you can see D2 is negative, therefore the positively charged particle will get attracted towards D2. Now it is moving through the electric field to reach D2. In electric field, you know the charged particle will get accelerated. Therefore, again its speed is increased and it becomes V1. Reaching at this point, now it enters the D2. But inside the D2, there is no electric field, only perpendicular magnetic field is there. Therefore, the charged particle will follow a circular path like this. And at the moment it reaches this point, the polarity of the D's are changed. Now the D1 is negative and the charged particle is attracted towards D1. To reach D1, it has to travel through the electric field in this region. Therefore, again the speed is increased and reaching this point in D1, speed is again increased to V2. The same process will continue. Inside the D1 there is no electric field, only perpendicular magnetic field is there. So it will follow a circular path. Then at this time the polarity is changed. That is, this one will become negative and this will become positive. And to reach here, the charged particle has to cross this electric field. Again its speed is increased to V3. And this process will continue and the charged particle will follow a spiral path and finally it will reach this point. And you can see each time when speed is increased, its radius also is getting increased. And finally the radius of the path will become the radius of the D's. And from this point, the charged particle will come outside. So let us find out the cyclotron frequency. We know for circular path, magnetic force will act as centripetal force. That is why the charged particle is following a circular path. What is magnetic force? It is Q into V cross B equal to what is centripetal force? mv square by r. All these are the same derivation we have done in the last class. Therefore, V cross B we can rewrite as Q into Vb sin theta is equal to mv square by r. Since the magnetic field is perpendicular, theta is equal to 90 degree, sin theta is equal to 1. Therefore, QVB is equal to mv square by r, or r is equal to mv by qb. Using v is equal to r omega, we can write omega equal to, this one is omega equal to qb divided by m. If you get omega, we can easily find time period t, that is 2 pi m by qb, and hence frequency is reciprocal of time period, that is frequency of c is equal to qb by 2 pi m. Next is resonance condition. Resonance condition means we have seen that whenever the charged particle completes a semicircle, the polarity of the disk should be changed. It means the time required to change the polarity from positive to negative is half of the time period of the oscillator. The time required to complete a semicircle is half of the time period of the charged particle. Therefore, both should be same. That is, half of time period of charged particle should be equal to half of time period of oscillator. That is applied voltage. Or Tc is equal to Ta. If you take the reciprocal, we can write Fc is equal to Fa. That is frequency of cyclotron equal to frequency of oscillator or frequency of applied voltage. This is known as resonance condition. Next is maximum kinetic energy of particle. We know the charged particle follow a spiral motion, a spiral path, and finally its radius becomes the radius of the semicircle. And that is semicircular containers Ds. Therefore, the maximum value of radius is radius of Ds. We know radius is equal to R is equal to mv divided by qb. Therefore, speed V is equal to qbr by m. Then kinetic energy is equal to half mv square. Substituting the value of V there, we can write half m into qbr by m whole square is equal to half q square b square r square by m. But maximum radius of the charged particle is radius of ds, that is capital letter R. Therefore, we will get maximum value of kinetic energy by substituting this value of R there. That is half q square b square capital letter R square, that is radius of the ds, divided by m.